Describe how Java handles memory management and garbage collection. Very important concepts in Java. So if you have to explain the garbage collection, you have to understand the memory management also. We are going to understand this in very detail. Along with that, we are going to cover a lot of related interview questions that can come around this one. So first we are going to see, whenever we are seeing memory management, so memory is divided in Java into multiple areas. So what are those multiple areas? First is heap area, second is stack area, third one is the meta space, and meta space, this is the same one. If you go previous to the Java 7, this was the same name that was it was known by different name, permanent generation. Before Java 7 and before were the same name was with the permanent generation, so name was changed to the meta space. Number 4 area is PC register. PC means program counter register, and number 5th is the native method stack. Okay, so these are 5 areas of Java memory. When we have to everything that we have in Java gets fit into these 5 areas. So let's see. So this is one example program that I have written, like Java memory management, where I have tried to put in everything that can come under Java, right? So in Java we have instance variables, we have static variables, we have constant also, and we have main methods in here. Inside that main method we are creating an object. We have couple of methods also. We are calling that method first, this method ultimately calling method 1, this method 1 is again calling method 2, and it is doing certain things during the execution. So when we have to understand the memory management, we have to see what, when all of these things are there, where they are getting stored in the system. For this only we have memory management, right? So we have different areas and we have to fit in all these attributes, all these components of our program in different systems. So let's see at which place, at which area, which component gets stored. So coming back to the whiteboard, heap stores all the objects that gets created into the system, and heap area is also further divided into young generation, and old generation. So we will come to this one in a bit. Okay, so first let's see which components of the program are gets stored at which place. So all the objects that we create, they actually gets created in the heap area, and whatever that reference variable that is there. So if you see, so this is the object that is being created, so this object will stay in the heap area, but this variable, that reference variable that is there, that will stay in the stack area. So in the stack, what all things that we have stored, it stores variables, local variables basically, call stack, whenever we have calling 1 or 2 methods in a stack, so that stack gets formed, that call stack gets stored in the state, method arguments, and return values. All of this gets stored in the stack area. So when I say call stack, so let's, if I debug this one just to showcase this part, what is the call stack that we are talking about, right? So we all know that execution starts from the main method only, right? So this is the first entry point. Inside this we have call to other methods. So let's say this one. So I will go into this main method that is there. So this is the main method, that first method call that has come into this one. This method is calling again method 1, right? So inspect this one, this area, debugger area. So method has, this is the main method that is coming at the bottom. This has called the method. And if I go deep into this one, I will get one more call stack in here, right? So you see the method one is coming in here. So if I go deep down into this one and come again method 2, so I just came out of this one method 2, right? So I can see the call stack, right? So this is the main method called method called method 1, and this is the structure that I can see. This is the call stack that gets stored in the stack area. So whenever we have and this is actually main thread execution that is happening. When we have multi-threaded environment also, all the threads has its own call stack, and that all of that gets stored in the stack area, and every thread gets its own stack. It gets its own stack memory in that. And during this time we have to keep in mind that all the objects that are there, they are still residing in the heap area. Only reference variable is there in the stack area. So if you have understanding about it, so whenever you are writing the program that is highly concurrent, so you will get the understanding that object is shared throughout the stack that we have, all the stacks that are there. So that sharing has to be managed properly. Okay, so this is about stack area. Coming to the meta space, what is that we have stored in the meta space? So it stores the class metadata. It also all the static variables gets stored in here. Constant pool gets created in this meta space. Along with the class metadata, we have method metadata also. This gets stored in the meta space, and this is a permanent generation. We already told that before Java 7. So if interviewer is asking this one, so get clarity, like this is the same meta space and program generation, it's same. And this class metadata, method metadata, static variables, constant pool gets stored in this meta space. So if I take this one, so this is the static variable that is going in the meta space. This is the static variable constant that is going in the meta space. So constant pool comes into picture when we are playing around the string. Whenever you create the string, all the string gets stored in the constant pool. That constant pool resides in the meta space. What is this program register? So whenever we are executing lines of code, right, so the current instruction that is being executed gets stored in the PC register, that is the program counter register. Native method stack, so all the methods that are written in the C language, they are not written in the Java language, right? So that execution space of those programs that are in C language, that gets stored in the native method stack. Okay, so this is how the entire memory space is divided, right? So Java memory area in heap, stack, meta space, and program counter register and native method stack. Now let's go deep into the heap area that we have. So we will understand more about the heap area, how the object allocation happens in here. So this heap area, as I told, it is divided into young generation and old generation. Young generation is further divided into Eden space, and we have survivor space. Inside survivor also we have two names, S0 and S1. That is how JVM has, like Java terminology has given it the name. And under old generation is also known as tenured generation. So whenever any new object gets created first time, that is going in the young generation, and inside that young generation, that gets a space in the Eden space. So whenever that object first time getting created, that will be allocated in the Eden space. So let's say at the same time there is a garbage collection. That is the second part of this video that we will be coming into. Garbage collection is the process of managing the memory automatically. To that work is done by the JVM itself. So if you understand C language, if you know the basics, In that language you have to manage the memory yourself in the programming, like you have to allocate, you have to deallocate the memory during the execution of the program. But Java has this Java has automated this process. I don't have, as a programmer, I don't have to worry about the memory management. That is being taken care by the Java itself. So whenever that automatic memory deallocation process is running, what it does, when the objects that are not in use, it removes those objects from the memory area and reclaims that memory, so that can be used by another object, another stack in the system. Okay, so whenever, let's say, the first cycle, where is that, let's say we are running, let's say the first cycle of that garbage collection is running. So in that garbage collection, some of that object will be reclaimed, like their life is very less, so they will be removed. But some of the objects will be in such a way that they are still in use by some other reference variables, so they won't be reclaimed. So these objects will be reclaimed, and these objects will move into further space, like is the survivor space. And inside that survivor also they will get into the S0. So let's say these 2-3 objects got into the S0. Okay, again there is a multiple cycle of garbage collection that runs. So next, like let's say the second cycle of the garbage collection runs. In this case, it found that one of the object is no longer in use, so it will reclaim that memory, but it will find that these two objects that are there, they are still in use, they are being referenced by some other variables. So these two objects will move to the further in the survivor space, that is in S1. Again there will be third cycle running. In this one, it will found that first one is, it might be this is no longer in use, so it will reclaim this memory, but it will found that this object is still in use, so it will further move it to the tenured, that is the old generation object. That is old generation, as the name suggests. It is like this, the objects in this space has longer life, they are like alive from long time. Okay, so I explained you, there are like heap areas, young generation, Eden space, survivor, S0, S1, and tenured generation, and how the object is moving from one area to another area during the garbage collection process. Garbage collection. So we are going to see the process, how this process gets kicked in. So first, what it is doing, first it does the marking. What kind of marking? Like used, unused objects. So first iteration, when it is running, it is doing this one. The second one it is doing is the normal deletion, that is also named as sweeping. So in this one, whatever unused objects are there, it reclaims those memories. Okay, third process is, that is the compaction. During the compaction, so whatever we have deleted, those memories will be stored, like those memory still will be in the system in terms of fragments, right? So this compaction process clears those fragmentation, so that they are properly available to be claimed by another objects. Some of the key concepts during this garbage collection process that we should understand. First one, maybe these keywords that you will get to know, that is the stop the word. This is the one of the event, that is, this is how the name is known as, and the second one is like you should know about minor GC, and the third one is that major GC. So stop the word means whenever that garbage collection process is running. So garbage collection process is also running as a process, right? So it does one of the threads that is running doing the garbage collection process, right? So sometimes there is a chance that all of the threads, all of the concurrent programming, that all of the cores that are there in the system are taken care by are occupied by the GC itself. So in this case, what happens, like all the application threads will get paused. This is what is the stop the word, that is garbage collection is running, and it is important because there is not much memory available for other objects to be taken care. So in this case, garbage collection threads takes priority, it runs, and in that time application threads gets paused. Okay, so that is what is known as the stop the word. So what is minor GC? Whenever garbage collection process is running and it is reclaiming the memory from the young generation of the space, that is what is known as the minor GC. Major GC, whenever it claims memory from entire heap, including survivor space, tenured generation also, that is what is known as the major GC. Now let's cover like last section of the video, that is related interview questions. So first one is what is the purpose of garbage collection in Java? So again, automatically reclaiming the memory that is not being used by any other object, any other system. So that is the automated process of the Java that it does. Explain the different generations in the Java heap. We already understood this one. What are the main types of garbage collectors in Java? So this is something main type of garbage collectors in Java. So that is something that we did not cover in this one. We covered how like what is the process of the garbage collection and how it works. So let's see what are the main types of garbage collectors in Java. Serial, parallel, and concurrent mark and sweep is there, CMS, and G1 garbage collector is there. So serial is something that is name suggests that it will execute the garbage collection process serially to the application threads that are there. Parallel it's something that it will run garbage collection threads parallelly to the application threads. Concurrent mark and sweep is that like it will mark those objects and it will sweep, that is means like it will delete those objects, and it will do the things concurrently to the application threads that are there. So these are the 4-5 types of the garbage collectors that I will create one follow video. Garbage collection in itself is a big concept, right? So I want to cover that separately. So just after this video I am going to cover that one. So whatever you not understood, we'll cover that there, and it will give the deep down understanding of that. So coming to the next question, how does the G1 garbage collector work? So this is also very important. So I want to cover this separately because this video is getting lengthy. So I want to cover this separately. So bear with me, and maybe by the time you are watching this one, you will get this one. So go ahead and check the description and the playlist also. You will get that. What is stop the word event? We briefly cover this one. What is the difference between minor and major garbage collection? We also saw this one. So the next question is, how does JVM determine that an object is no longer in use? Very important question. So let's say we have a classes like C1, C2, C3. So we have created this object, right? And this object is being referred by O2. This object is being referred by A3. So this is the objects that is being created, right? So during the execution of these things, maybe O1 has done its job, like there is no so during the execution of this one, it will found that O3 is no longer is in use, right? So it will continue its execution, right? So there will be a point where O3 is not needed in here. Okay, so the same story is in here also. O1 is using O2, right? So whenever it is running, so there will be a point when the job of O2 is done and it won't be required there. So this is how when we say O2 is no longer being referred from like O3 is not being referred in O2, so that is where JVM will decide that it is no longer is in use. The same is with the O1 also. O1 is using O2, but there will be a point when it will say that O2 is no longer is in use. And the same story goes with the O1 also. When the thread execution will come out of that one, then it will decide that these objects are not used, and sequentially it will say that that is how it will mark those objects as unused, and it will, during the garbage collection process, it will be claimed by the garbage collection process, by the memory. This is how it determines that object is no longer is in use. What are some ways to tune garbage collection performance? We'll see in the garbage collection. Explain the concept of meta space in Java 8 and later. The meta space part we briefly covered this one, like meta space, that is it's the same name as a permanent generation, but it was the name before Java 8, and it stores the class metadata, it stores method metadata, constant pool and static variables also. But if you want to dig deeper, let me know in the comment section. I'll try to cover this as well, but briefly this can be said that this is the concept of the meta space. That is how these things that are stored in this one as part of the Java memory management. What is memory fragmentation? When garbage collection deletes those unused objects, those fragments gets created in the system, in the memory. So the compaction process of the garbage collection runs, that is where memory fragments gets cleared. Can you explain how ZGC achieves low pause time? So this is again part of the garbage collection. I want to cover it separately. Why might an application choose ZGC over G1GC? What's the default enabled garbage collector in Java? So whatever related to garbage collection, there are many questions that can appear around this one. I want to cover this separately, so let's wait for that video. I'll cover that there. Okay, so that is it about this one. I'll see you in the next one. Till then, take care. Bye bye.